Hello, everyone, and welcome to our webinar, Top Security Features for Your Progress OpenEdge application. My name is Jessica Malakian, and I'll be today's moderator. So let's start by quickly introducing to you our speakers for today. Today, we are joined by our speakers, Marie Candela, Chad Thompson, Rob Marshall, Marv Stone, and Roland DePiper. Marie Candela is currently a member of the OpenEdge product management team, providing a focus on data management. Marie joined Progress in 2006 to be the development manager for the OpenEdge database, a role she enjoyed for several years. Moving from development to release management to product management, Marie now gathers requirements, defines features and capabilities, and drives their rollout and delivery in releases. Chad Thompson is a senior principal consultant with Progress Services. With over 20 years of industry experience favoring reality over formality, this passionate technology advocate has experience and insight that shed light and produce the aha effect on some of the darkest corners of application integration. Rob Marshall is a senior principal consultant with Progress Services. With over 40 years of experience working in the computer software industry, specifically with the Progress family of products, there isn't much that he has not dealt with. He is skilled in OpenEdge, Oracle, SQL Server, databases, pre-sales, and all phases of software development. With a strong program and project management professional, he recently completed his Doctor of Philosophy focused in information assurance and cybersecurity from Capella University. Marv Stone is a principal sales engineer at Progress with over 30 years of experience in the IT industry, focusing on business application development and modernization. Since joining Progress, he has worked closely with customers and partners to help them get the most out of their OpenEdge-based solutions. His area of expertise includes Pro2, Progress Application Server for OpenEdge, and authentication strategies using the OpenEdge Authentication Gateway. Known for his practical approach and collaborative style, Marv supports teams through technical challenges and modernization efforts, always aiming to deliver solutions that are both effective and sustainable. And last but not least, Roland DePiper is a senior principal consultant. Some say he naturally faces magnetic north and that wherever you are in the world, if you turn your radio to 88.4, you can actually hear his thoughts. All we know is that he joined Progress Software in 1995 and has even since been helping customers make the best use of the latest Progress technologies. I'll now turn it over to Marie to start the presentation.
Thank you, Jess, and what a wealth of experience we have here today. It's an overview of the security features available in OpenEdge 12.8. OpenEdge 12.8 includes several advanced security features designed to supplement operating system and file system security, helping organizations protect themselves against breaches and make data protection more robust. So with OpenEdge 12.8, you have these features already either in your toolbox or waiting for you to pull them down to add to your toolbox to help you protect your world. I'm going to start with a little context setting on why security matters. As technology evolves, so do the methods used by the cyber criminals. Also, our mission-critical applications are not always kept up to date, and that makes them remain vulnerable to cyber attacks. Insider threats can be either accidental or intentional and can also steal or delete data and cause harm. And now we've got the rise of AI. Cybercriminals are increasingly leveraging artificial intelligence in various ways to enhance the effectiveness of their attacks. McAfee reports a 70% increase in the use of AI-driven attacks. We've already seen AI create automated phish messages, ransomware targeting, and data theft. It is highly likely criminal use of AI will increase by 2027 as AI becomes more widely adopted in society. This chart is pulled from the annual report that IBM commissions about the cost of a data breach. Starting on the left in year 2018, the average total cost of a data breach was $3.86 million US. Last year, 2024, that number has risen to $4.88 million US. That's an over 26% increase in a 6-year period. And then don't forget, there are the intangibles. A significant breach will not only cost you money, but it can also greatly impact your customers and your reputation. It can have you involved in long, drawn-out legal investigations. The impact of it that you have to devote can erode your current plans and your roadmaps for future development as you're having to increase your investment in remediation and recovery. And then finally, there's that time that is lost chasing ghosts and dead-end leads. That's time that you can never get back. So how can we survive the security war? How can we improve our odds? Really, it comes down to preparation in all aspects of your operations. So now we're going to look at features in OpenEdge 12.8. Some of these features are old friends that appeared along the way to 12.8. However, they are all present at this time with the 12.8 version. First, we'll take a look at protecting your data. I'm going to start with a relatively new feature for us, dynamic data masking, also referred to as DDM. A security administrator or a database administrator might need their OpenEdge business applications to support specific data privacy and integrity for compliance requirements, for example, like GDPR or HIPAA. Data masking offers a simple approach to obfuscate the sensitive data at runtime based on user role permissions. In a nutshell, dynamic data masking required functionality you can see here on the left, where the person is able to see the full data for that field, for the credit card ID. An unauthorized person will see a masked version of it, where here it's only revealing the final 4 digits for an individual's record. The key requirement data masking for OpenEdge is to prevent sensitive information from being viewed by unauthorized users, but there are also some specific OpenEdge requirements. Those are that you do not have to make changes to your application code. You also don't have to make changes to your underlying data. It has to be configuration based so that there's the flexibility for different organizations to do different masking. And it also has to have high performance and high availability. That results in these key features of defining an administrator and other users who will each have your respective mask patterns depending on your role. There are audit events in place to track changes to enablement and rules. The masking itself happens in the presentation layer of the specific clients. This is how we maintain that there's no changes to your underlying data. So at runtime, as you're viewing this information, the masking functionality will be consulted and will apply appropriate masking to appropriate fields for the end user. This is done through ABL, SQL, AppServer.NET, and Java. If there are changes to the dynamic data masking while the database is live online, those changes are propagated to connected clients. What this means is that you are not taking down your database in order to apply changes. It also means that you are not having to restart your connected clients to obtain the changes as they happen. And then finally, we also have a dump and load aspect for DDM data for easy transition. You're often moving from development to production, or maybe if you have multiple databases in production at the same time and you want to propagate identical masking protocols to each of them. Now we're going to move on to transparent data encryption, or TDE. This is one of our old friends, but it is at the opposite end of the spectrum of your data. This is about data at rest, what's stored on disk. Transparent data encryption promotes data confidentiality using industry standard encryption ciphers and secure key protection and storage to help resist the impact of attacks. TDE obfuscates the data on disk in backups, binary dump files, after image and before image files, or audit archives. It requires no changes to your application, user procedures, or DBA management processes, therefore minimizing the cost of introducing it to your production operation. It supports compliance with various different regulations in the industry, like PCI, Sarbanes-Oxley, HIPAA, GDPR, etc. OpenEdge transparent data encryption obtains its transparency from being transparent to the application, in that the application has no idea that the underlying data is stored in an encrypted format. It supports full index query support, and there's no need to move your data. It's flexible. It can encrypt depending on your storage type, from individual objects all the way up to entire areas. You can change encryption policies online. It is the storage engine block manager on disk that is performing the encryption on a write and the decryption on a read from disk. TDE is security focused in that it provides encryption key storage. It supports industry standard ciphers, and it also limits access to physical data. I want to do just a very high-level overview of the key components. As we said here, your data is flowing internally in clear form between the database and the server. So you'll see is on the left, anyone accessing that data will see it unencrypted. However, when that data is written to disk, it will be obfuscated, as you see on the right. We do this through use of a key store. The top item, the database master key in green, we're going to see a little bit more about that later. The key store is maintained separate from the database. It is separated so far as to not even be included in your backups. It contains information needed to be able to get to the ability in the database to do the encryption and decryption. We have the encryption policies, which, as I mentioned earlier, you will configure, and we maintain versions of those policies and also what state they're in use. These are maintained in a reserved encryption policy area in your database. Lastly, we have the configuration library, which brings the industry standard libraries to OpenEdge. These are all on a third-party basis. And then finally, at runtime, we have the encryption cache, which contains a mix of elements from those items on the right to be able to do the live real-time encrypting and decrypting of the OpenEdge data at rest. Since we're talking about encryption, we'll now look at the hardware security module support, or HSM. An HSM is a physical device that's designed to securely generate, store, and manage your digital keys and perform cryptographic operations. OpenEdge TDE supports integration with a hardware security module to give you options for managing your key store security. TDE uses the PKCS#11 standard to interface with an HSM. This, in turn, makes the TDE key store actually a client of the HSM. HSM is about the TDE keys. The key store master key, or KMK, is the top-level key in the OpenEdge TDE encryption hierarchy. Think of the KMK as the key that protects all of your other keys. The KMK encrypts and protects the contents of the TDE key store, which you recall is kept separate from the database. The TDE key store stores the database master keys, the DMKs, and is used to encrypt actual database data. That's enough about keys. This is the point where people's eyes start to cross when we talk about all the keys. So this TDE key store contains a number of elements to be able to access the OpenEdge database. But one of the things that is important in this key store is the key store files KMK. An HSM may be in your enterprise, and an HSM also has the ability to contain all of the pertinent information to be able to create the key store files KMK. So when we have TDE integrated with an HSM key store, that HSM KMK supersedes the one that's in the TDE key store. In summary, when you use the HSM to provide the KMK to the TDE key store, you're transferring the management of your key store master key to the HSM. Additionally, if you have multiple OpenEdge databases using TDE, you can keep all of your KMKs centrally in the HSM. On earth would someone use an HSM with OpenEdge TDE? Well, it offers enhanced key protection. It physically separates the key store master key from the TDE key store, and it separates that even further from the encrypted data. Administration by a security administrator of the HSM will create a separation of duty from the database administrator. What this means, it's like when you leave your car at night, you go in the house, you take your keys away from the vehicle. And if you put them on the shelf or hand them to somebody else to take care of, you have now moved them a further step away. An HSM will provide two-factor authentication for key store access. So if someone obtained your key store file, it can't be decrypted without HSM authentication. The HSM becomes the first authentication to access the TDE key store. HSMs generally support a number of industry standards. Most of these are very stringent regulatory requirements. And then finally, there's the operational integration that OpenEdge brings to this. The HSM integration is embedded in the TDE key store management utilities, so there's no need for external scripts or tools due to the seamless administration for DBAs and security administrators. That's Chad.
All right, I'm going to cover the updates to the OpenSSL cryptographic library that is deployed with OpenEdge 12.8 series. The previous versions of the OpenSSL library that were deployed with OpenEdge were version 1.1.1. That library has now been updated to 3.1. What that means for consumers is now the OpenEdge platform supports TLS or SSL 1.3. TLS versions prior to TLS 1.2 will not work with the OpenEdge platform. So a minor switch in communication has to occur. The benefit of TLS 1.3 is most notably faster handshaking, faster encryption, and much more solid support for strong ciphers and encryption suites. A key takeaway to the upgrade to this new OpenSSL library is the support for the encryption at the Java layer, and in specific, the HTTPS or HTTP over SSL, that's integrated into the PAS for OpenEdge product. One thing that bears noting also is that the version of Apache Tomcat that's released with PAS has been brought up to the 10.1 series and the most recent strong validated version of that, including the Spring security framework and the core Spring framework have both been brought up to the Spring 6 series. One other key point to note is anytime we talk about OpenSSL on the OpenEdge platform, that includes not only the Java layer, but also the runtime AVM or ABL level. When you're trying to communicate from your ABL code to external systems, or whether you're integrating with all the other tools that the OpenEdge platform provides. Remember that the TLS versions are now significant. One way to know what version or what support your particular version of OpenEdge has, what does it support from a cipher's point of view, is to simply query the OpenEdge library that is built into your OpenEdge deployment. This is done using the SSLC command from your DLC bin folder. In there, you can list the different providers, the different ciphers, or different digest algorithms. For the most part, anything that SSLC command returns is generally supported by the OpenEdge platform. Within the OpenEdge documentation, there are a complete list of OpenEdge supported ciphers, and they are a very strong suite. From a ABL point of view, you can look at the security policy system handle documentation and look under symmetric support. That attribute will list all of the abilities that OpenEdge provides for you from a stronger TLS point of view. From the Java perspective, all of the OpenEdge components that require a Java runtime now support Java 17. And so it's important that you're going to want to have a strongly implemented version of Java, say Adoptium Java, the Oracle Java kit, 17 or better. And then bear in mind, you'll also need to maintain that version, continue to update it as it's not deployed with your OpenEdge installation. From a services deployment point of view, the Progress Application Server for OpenEdge, as I mentioned, PAS for OpenEdge, supports OAuth 2 authorization. This is where you can configure your PAS instance to accept an authorization token from an external service. That external service would provide you with a JWT, or a JSON web token. One of the new features inside of the PAS OE platform for 12.8 is we now permit JWE, or JSON web tokens, in encrypted format. The difference being JWTs, while they are encoded in base64 format, they will still need to be decoded from base64, but the contents can now be encrypted. This is the JWE standard. From the Progress Application Server point of view, once a JWT token is accepted, through the process of filters and the security filter chain provided by Spring, that OAuth 2 token then is converted into a client principal object that is made available to your ABL code that is running underneath your PAS service. And it bears noting HTTPS, or HTTP over SSL. It is very important to remember that you will want all of your services, your PAS services, to use HTTPS, including those that are internal to your network. One of the key takeaways here is TLS, or OpenSSL, in its entirety, from end to end, from the client and as far back into your network as you can manage. And it's at this point where Rob can address SAML and Onward.
All right, at this point, we're going to talk about the enhanced application server. The main thing that this supports for us within the PAS framework is SAML. And SAML is an open standard that's often used to exchange authorization and authentication data between security domains where we're trying to typically do things like single sign-on. We support SAML 2 within PAS, and it basically provides things, communication between XML, where our identity provider, similar, you can use things like Okta, or there's a number of them out there, that would connect to our service provider, which in our case is typically PAS, where we authenticate against a customer's Active Directory or LDAP. where we're verifying single sign-on permissions, comes back to PAS, and then, as Chad was just saying, we can get a client principal object that we now have access to within our application. And once PAS is configured, it can convert that SAML into a client principal. One other thing we now have is called a protected compile. This helps us secure all of our compiled code, so that way we can get a digest number, which you may have seen when you download stuff off of some customer sites and some providers. It'll say, here is a checksum. And that checksum is built at the compile time. So that way you can have routines on your server that look for the checksums of your procedure libraries or of your R code. And it alerts if those have changed. So therefore you get, advanced notification if somebody has tried to manipulate your code that's out there in your production or controlled environments. So that way it helps to prevent unauthorized modifications. It verifies and enhances integrity of your development process because you have these checksums. So when you do your rollout of your new code every X period in time, when it rolls out, there's a new checksum code that gets put into the security routines. They scan for that. So therefore you can say, here is everything. When we create these protected compiles, we use a couple of tools within the Progress stack that are new. One of them will package all of our R code and image files into a new type of an archive. We're used to seeing PLs for procedure libraries. Now this is an archive file called an APL, an archive procedure library. And then we can sign that archive file and generate that checksum. We can sign our code, so we can organize and store all of our APL, our archive procedure library. We can also allow to manage and execute our code within procedure libraries, which we've done before. Procedure libraries have supported that. But now we can also say this archive procedure library, this APL, can go through and say, oh, this isn't the checksum I'm looking for, and therefore will not run that R code. So it gives us a way that we can stop people from trying to manipulate code, change a new .r out there, and then potentially get access to the application where they should not have. We have an external security administration tool called ESAM. It helps doing a lot of things out there, specifically for testing. It is an OpenEdge security control, and it's made to help us secure OpenEdge on a specific environment. So it's not generic across the board. ESAM, you would configure it up for your PAS environment on Windows, for example. You would have a different configuration for it for Linux, because it is specific to the OS and the products that you're trying to work on. In here, you'll also see a link to the documentation, which is quite extensive, on how to do different layers of governance when we install the ESAM tool. How ESAM works? Well, it helps prevent attacks from directing Progress utilities, right, from outside the scope. So you can't, for example, pro-win from outside of the OpenEdge implementation directory, because that's where all of the base stuff that we supply and that we patch and everything else is stored. So, it's checking those checksums, it's checking everything else within there. We can have multiple versions of OpenEdge on a box. Notice that this has a requirement of version 12.6 or better. So it helps go through and say, okay, I have 12.6, I have 12.7, I have 12.8, I have 12.8.2. We can lock down each of those differently. It is an inherent part of the installation, because it will say, now I'm installing ESAM. It's automatically installed behind the scenes when you do an install. So if you're installing 12.6, then you'll see a pop-up show up in Windows that says, now installing ESAM. On Linux, you don't see so much. It'll just be a box that pops up for a second and disappears because it's automatically done silently in the install. We support only 64-bit installations, whether it's Linux or Windows. It does not support 32-bit versions of those platforms. So that is the only caveat we have. OpenEdge now has a huge number of algorithms that we support with ESAM. There's a whole list of them right there. Depends on what you need. There's a bunch of the new ones. They have deprecated a bunch of the old obsolete ones that have been, shall we say, known to have vulnerabilities. We also have an OESEC tool, which helps us test security and validation. So it simulates a SAML2 identity provider server, and we can test our OAuth configurations and our SAML configurations for PAS without having to have the full configuration set up. So if we're defining up an OAuth configuration for single sign-on to another customer's Active Directory, we can verify that we have all of our configuration on our side set up. And that way, when we get the configurations and trust relationship set between PAS and the customer that we're eventually trying to single sign on to, then we'll have that. But we can test everything on our side in advance.
Okay, application is secure, check. But what about the database? Database security is something that people have been doing many different ways through the years. A very common and popular way of doing that is by storing users and password information in the database itself. Well, the issue with this is that people have to actually connect to the database to see if they have permission to connect to the database. And there's also other ways that people get access to your information through ODBC and JDBC connectors, reporting, non-OpenEdge applications. All of these different connection requests are coming to the database, and you need to make sure that those are secure, that those people are legitimate users, and that they have access to the database. That's what the OpenEdge Authentication Gateway does. In this diagram, you see where a client is transmitting credentials to the database server, requesting connection to that database. The database then passes those credentials on over to the OpenEdge Authentication Gateway. In order for this to take place, you simply need to activate the OpenEdge Authentication Gateway. It is a database feature that needs to be turned on. And once it's turned on, it will handle all of these requests for connection. The OpenEdge Authentication Gateway is a centralized authentication point for any client that makes a request to connect to a particular database. So once those credentials that have been passed are validated, the Authentication Gateway creates a client principal object. That client principal object is then validated again before the client is allowed to connect to that database. Each client that connects to the OpenEdge database, once Authentication Gateway has been activated, is authenticated. Those can be read from user account and sources in the database. They can also be authenticated via LDAP or Active Directory, the OpenEdge OE realm. It can connect to another database to see if that person is a legitimate user. You can also use a text file, so you can literally have username and passwords in a text file, and the Authentication Gateway can use that to validate a user. This is great for testing. It's really handy, should not be used in a production environment. Beyond just these type connections, anything that needs to connect to the database will need to go through the Authentication Gateway. That includes database tools, database utilities, all ABL constructs. All of these different connection types will need to be validated by the Authentication Gateway once it's activated. So the Authentication Gateway enhances the security of your OpenEdge environment by supporting the latest security standards. It redirects all accesses for database information to a secure token service, Well, that will then confirm the user's legitimacy. This is a secure token service of your choosing. Many different types are supported. This prevents clients from going around authentication and accessing your database directly, which helps your company support any kind of industry regulations you need to meet, and it minimizes the impact to your business because there's little or no changes required at the application itself. The OpenEdge Authentication Gateway is part of the Progress Application Server for OpenEdge. It comes bundled with that product, but it's also available if you're still using the classic application server. It's an add-on to that and can still be used in your OpenEdge environment. Now, many of the security features that you've been hearing about today have been bundled together to make it easier for you to leverage these tools. We now offer the OpenEdge Advanced Security Package. This security package includes transparent data encryption, which is the data at rest is encrypted as described by Marie. It includes the JSON web encryption. Chad talked about how this is used to secure the payload of JSON web tokens. The advanced security package also includes the hardware security module, which can be used in tandem with transparent data encryption to provide the highest level of security when storing and using cryptographic keys. And finally, the package also includes dynamic data masking, which Marie covered earlier. This helps companies comply with regulations by making or masking sensitive data fields from unauthorized users at runtime. And that's me.
So welcome at my part of the security webinar. My name is Roland de Pijper. I'm a consultant working from the Rotterdam office in the Netherlands as a consultant for professional services. And I would like to tell you a little bit about our application quality and security management offering, in short, QSM. What QSM is mainly about is what you've probably seen in the rest of this webinar, that we have a lot of possibilities to detect configuration issues, runtime security issues. This QSM is mainly focused at source code, because in the end, that's where it all starts. I mean, what your application is all about, it's a lot of source code, ABL code. And that's really where these kind of security threats can start from. So we help you to detect the vulnerabilities in the source code, and we do that continuously. So QSM is an online platform using your CI/CD pipeline, or even at every commit. You can upload your code and it gets evaluated, and all the security risks are being detected in the platform. The first thing that you can start with is adding your objectives. Just like with what you can see also in the picture, things like maintainability, architecture, open source health. Nothing is perfect, probably also not your source code. So you can set your own objectives, like I don't want to have any medium security issues, or I don't want to have any high level security issues. Based on those security settings, you can dive into the different models that are in there. We supply the most common security models out there. Like what you can see here, there's an ISO 50055 standard for it. SIG, that's the company behind this platform. That's what we white labeled this offering with. They also supply their own kind of rule sets. Most commonly is the OWASP Top 10. So the OWASP Top 10 describes the kind of security issues. Together with SIG, we have implemented those rules based on ABL code, because they are very much specifics out there. So how does it all work? First of all, you get an overview. This is an overview of the complete source code base with all the security topics that can be found in there. What you can see in here, there are two kind of different sets of security rules: cryptographic failures, A3 injection, which are being detected in my source code. You can also see the severity, the activity over the last so many months. And the last time when I performed a scan, well, this is a little bit outdated. It's an older picture, but normally every night when you build your application, when you run through your pipeline, this gets uploaded and gets checked by the QSM platform. On each and every security issue, you can zoom in. The platform will bring you to the exact line of code in your source base. And there it's up to you to make decisions. It's not that everything that's in there needs to be fixed. Maybe you can say, well, okay, I will add this finding here because, yeah, it's an MD5 algorithm, but it's a high risk, but I know that it will probably never be exploited. So I can change the exploitability, or I can even change the severity. So it's up to you to decide if you're going to fix it, if you're going to postpone it. That's up to the developer itself. In fact, you can even add your own findings to it, because not everything which is described in the security rules, like in the OWASP top 10, is covering all of the possible risks. So even if you find something in your code base, they say, well, this is kind of fishy, this is something that we need to tackle, you can add your own finding in here, so that can be followed up by yourself or by the other developers within your team. In the end, when you detected those issues and when you decided how to follow up, you can add that to your issue management system. In the example here, I've taken up this specific finding, I add it to my task list, and I can copy paste this into my Jira or whatever kind of issue management system you are using to be followed up maybe in the next sprint or by some of your colleagues. So that was my part of the security webinar. I'm going to hand it over to Jessica so she can wrap up. Thank you for listening.
All right, thank you so much, Roland, and everyone who spoke about our security capabilities today. If you have any questions, just reply to the follow-up email you'll be receiving, or feel free to reach out through the Ideas portal or the CVP. Those channels let us respond even more quickly. So thanks again to everyone who attended today's webinar. We really appreciate your time and engagement. Have a great rest of your day.